Hi everyone, today we are going to continue our discussion about applying the remainder and factor theorems. Our learning objective for today is for you to be able to say, I can use synthetic division to factor polynomial functions and to find every zero, which once again that means x-intercepts, of a polynomial function. Our warm-up for today is for you to divide 4x to the fourth plus 29x cubed plus 4x squared minus 14x plus 6 divided by x plus 7. Please feel free to pause the video and divide this on your own. And when you have an answer, please restart the video and we'll see how well you did. So hopefully you notice that we are dividing by a divisor that is a linear binomial, which means that we are allowed to do synthetic division. So in order for us to do synthetic division, we are going to let x equal the x-intercept, or the zero that would be produced from this binomial, and that would be -7. So I'm going to place -7 inside of the box. And I'm going to make sure that every degree is represented before I write down the coefficients. And it appears that we have 4, 3, 2, 1, 0. Every degree is represented. So I'm going to write 4, 29, 4, -14, and 6. I'm going to put a vertical line between my last two numbers and a horizontal line going straight across. And I'm going to bring down the first term, and I'm going to remember that I add above the line and multiply below the line. So now I'm going to multiply. -7 times 4 is -28. 29 plus -28 is 1. -7 times 1 is -7. 4 plus -7 is -3. -7 times -3 is +21. -14 times plus 21 is 7. -7 times 7 is -49, and 6 minus 49 is -43. So my answer is going to be 1 degree less than what I started with. So I'm going to be working with a cubic, and this is going to be 4x cubed plus x squared minus 3x plus 7 plus, because you always need a plus, our remainder, which is -43, divided by our divisor, which is x plus 7. And hopefully you were able to get this answer correct, because synthetic division is actually going to be our foundational skill and the skill that we're actually going to be using for the next couple of lessons. So in this problem, we had a remainder of -43. So what if the remainder is the number 0? What does that actually mean? And this means that if there is no remainder, it divides into that polynomial evenly. And it is actually a factor of the polynomial. So whatever that binomial is, that's actually going to be a factor of it, meaning that you could potentially factor that polynomial completely. So the polynomial factor theorem says a polynomial f of x has a factor of x minus k, and we can put that into parentheses, if and only if f of k is equal to 0. So it is a factor if you find that your remainder is equal to 0. And just like a quick reminder from geometry, especially those of you who took honors geometry, the language of if and only if means that it works both ways. It's not just an if-then statement. So that theorem can also work as a converse as well, and it is still true. So this theorem is also saying that if f of k, meaning after you've done synthetic division, you end up with the answer of 0, then that means that x minus k has to be a factor of that polynomial. So you're going to see different types of directions, and it's going to be imperative that you recognize the difference. This first set of directions simply says, given the polynomial of f of x and a factor of f of x, which the factor is going to be a linear binomial, they're asking you to factor completely. So that does not mean that you're going to set it equal to 0. It means that once you get to a certain point, you're going to factor and break everything apart into different parentheses. So hint, after dividing your given factor, you're going to get some get a polynomial that's going to be below the line, and you're going to need to factor that quotient, and then you're going to rewrite all of the factors together. So this is what it looks like. They're going to give you a polynomial, you're going to see a colon, and you're going to see that x minus 3 is a factor of that polynomial. This polynomial is not factorable by grouping. You'll see that if you were to put parentheses around the first two terms and parentheses around the last two terms, there wouldn't be enough. Your two parentheses inside would not have anything in common, so factoring by grouping would not be appropriate. So therefore, we have other methods or other approaches. So I'm going to start off by letting x equal 3, because that would be the 0 that would be produced from that x-intercept, and I'm going to put 3 inside of the box. I'm going to make sure that every degree is represented, 3, 2, 1, 0, it is in this case. So I'm going to write down all of the leading coefficients, 2, negative 11, 3, and 36. I'm going to do synthetic division, and I'm going to bring down the number 2. 3 times 2 is 6, negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. 3 minus 15 is negative 12. 3 times negative 12 is negative 36. And 36 minus 36 is 0. We ended up with a remainder of 0, which is awesome. That means that x minus 3 is a factor of this polynomial. Up here, if you did not see that, you would be writing it as a remainder over the divisor. But in this case, because we ended up with 0, that means that x minus 3 is a factor of this polynomial. And what we have so far is x minus 3 times 2x squared minus 5x minus 12. And now they're asking you to factor completely, which means that we're going to take this quadratic and break it apart even further into 2 more parentheses. So our first set of parentheses is still x minus 3. And now I'm going to factor this trinomial if I can. So I'm going to start off by splitting apart the 2x squared into an x and an x, or 2x and an x. And I'm going to look at the factors of 2, which are 1 and 2, and the factors of 12. I'm going to start off with 3 and 4, and then I'll work with 2 and 6. And my goal is to get a negative 5. So I'm going to multiply 1 times 3, and I end up with 3. 2 times 4, that is 8. Can I get a negative 5 from 3 and 8? The answer is yes. I can get a negative 5 by making 3 positive and 8 negative, and I will end up with a negative 5. So what I did is I multiplied 1 times 3, so that means 1x, since it's on the inside, will be multiplied by 3. Since I need 3 to be positive, I'll have a plus sign right here. I need 2 to be multiplied by 4 to make that 8. So 4 is going to go on the outside, just like 2 is on the outside. But 4 is going to be negative since I wanted a negative 8. And if you were to check that back out, you would end up with what you started with up here with this quadratic, and that is the full factorization. X times 3 times 2x plus 3 times x minus 4. Let's go ahead and look at letter B. This time around, they gave us the factor of x plus 1, which means that it would produce the x-intercept of x equals negative 1. And I'm going to put negative 1 inside of the little box. I'm going to verify that all degrees are represented, 3, 2, 1, 0. They are, and I'm going to write down all of the leading coefficients. So my vertical line and horizontal line, I'm going to start by bringing down the number 1. Negative 1 times 1 is negative 1. Negative 6 minus 1 is negative 7. Negative 1 times negative 7 is positive 7. 5 plus 7 is 12. Negative 1 times 12 is negative 12. 12 minus 12 is 0. We ended up with a remainder of 0, which is exactly what we want whenever we see that a factor is given. If you don't end up with a remainder of 0 and they give you a factor like this, that means that somewhere you made a small error along the way. So I have x plus 1 as a factor, and I also have x squared minus 7x plus 12 as a factor. And I can break apart this quadratic even further. So I'm going to write x plus 1 again because it is still a factor, and we're factoring this quadratic completely. And I'm breaking it down into 2 more parentheses. So I'm going to split apart the x squared into an x, and I have to ask myself what 2 numbers multiply together to equal positive 12 and together add to equal negative 7, and that is a negative 3 and a negative 4. Here is my full factorization. So the thing that I want you guys to keep in mind is whenever they ask you to factor completely, they already gave you one parenthesis, and that parenthesis needs to be included in your final answer. If you're missing that parenthesis, then you're going to lose out on points, and I just don't want that to happen. All right, so now recall that if f of k is equal to 0, then k is considered a 0 of that function. So what we are going to do now, in this problem, all we did was factor for a and b. Now we're going to be asked to factor and then find the other zeros. So that is what we are going to be asked to find. Now, if we are given a 0 of f of x, then we know the corresponding factor will divide evenly into f of x. We can use synthetic division to find the quotient, and then we will factor that quotient. And then when asked for the zeros, we must also set each factor equal to 0 and solve them. So what this means is that I'm going to give you a 0. And in this case, we are told that f of -2 is equal to 0 given this function. That means that one of our parentheses was an x plus 2, and it produced an x equals -2. So that number inside tells us what value we are going to use for synthetic division. So I'm going to put -2 inside of the box, and I'm going to make sure that every single factor, every single degree is represented, 3, 2, 1, 0. And I'm going to write 1, 8, 5, and -14. So now I'm going to bring down the number 1. -2 times 1 is -2. 8 minus 2 is 6. 2 times -6, or -2 times 6 is -12. 5 minus 12 is -7. -2 times -7 is +14, and -14 plus 14 is 0. Awesome. So far in terms of my factorization, I have x plus 2, because that was given to me up here with the f of -2 is equal to 0. And I also have x squared plus 6x minus 7. Now, what's different between the directions up here and what I'm about to do down here is that they asked you simply to factor completely. This one is asking you to find the other zeros, so you must set this equal to 0. But I can still continue factoring, and that's exactly what I'm going to do. I still have the x plus 2, and I'm going to split apart the x squared into an x, and I ask myself what two numbers multiply together to equal -7, but together add to equal +6, and that is going to be a +7 and a -1. So therefore, my zeros, every single zero, we already know that x equals -2 was given, but the other zeros, those are going to be x equals -7 or x equals 1. These are the other two zeros. And so whenever you're asked to find the others, I'm not looking for you to tell me what was given necessarily. The real answer to the question is x equals -7 and x equals 1. So to recap, they're going to give you an x-intercept, a value to work with, or a 0 to work with. That's the value that you're going to use synthetic division with. If they're asking you for the other zeros, you would still factor, but this time around you would set your factorization equal to 0 to find your x-intercepts or to find the other zeros. So I'm going to let x equal 4, and that's going to go inside of the box. This x equals 4 came from the parentheses of x minus 4, and I always like to establish that that's what was given to me before I get started. Every degree appears to be represented, so I'm going to write 1, 1, -16, and -16. I'm going to draw a vertical line and a horizontal line, and I'm going to bring down the number 1. 4 times 1 is 4, 1 plus 4 is 5, 4 times 5 is 20, -16 plus 20 is 4, 4 times 4 is 16, and -16 plus 16 is 0. So in terms of factorization, I have x minus 4 times x squared plus 5x plus 4, and I'm going to write equals 0 since the directions say find the other zeros. I'm going to factor this even further. by breaking apart the x squared into an x and an x, and what two numbers multiply together to equal 4, but together add to equal 5 is plus 4 and plus 1. So therefore, the x equals 4 was given, and the other zeros, that's going to be the opposite of what we see. We have negative 4 or x equals negative 1. And that is your answer. All right, so let's go ahead and flip the page. And we have these two questions, one that has a your turn and the other one is going to be a question that's a little bit different than the others. I'm going to put a bunch of stars next to this question, and I'm going to put the word unit right next door to it. And that's because this is a question that you will see on your unit test, so I want to make sure that you pay attention to it. This is making connections, and the question says, what is the value of k such that x minus 4 is a factor of x cubed minus 6x squared plus kx plus 12? So we have to identify that k value. So instead of this appearing to be a really intimidating question, this is what I want you to do. I want you to do synthetic division just like you normally would, but just know you'll be working with variables. So that means that we would still have x equal 4 that we will be working with, because that is going to be the x-intercept that's produced. So I'm going to put 4 inside of the little box. And I'm going to do synthetic division. I have every single degree represented, so I'm going to write down the leading coefficients of 1, negative 6, the letter k, and 12. And I'm going to do the process of synthetic division just like you would normally do. I'm going to bring down the number 1, and I'm going to write 4 times 1 is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. What I'm doing here is I'm adding. Remember, we add above and multiply below. So this is going to be k minus 8. That is the result. Now I'm going to multiply 4 times the entire quantity of k minus 8. So 4 times k minus 8 is 4k minus, and using the distributive property, minus 32. I am now adding, going straight down, and I'm left with 4k minus 20, because 12 minus 32 is 20. Now, in order for something to be a factor, this space should equal 0. So 4k minus 20 should equal 0. That's what we found every single time. And in this case, we obviously don't have a 0, but we need to figure out what k value would turn that into a 0. So I'm going to set 4k minus 20 equal to 0, and I am going to solve for k. So I'm going to add 20 to both sides. I end up with 4k is equal to 20, and dividing both sides by 4, we find that k is equal to 5. So now what I'm going to do is I'm going to verify that this is true. I'm going to verify that k should equal 5. By repeating the whole process again, I'm going to put 4 back inside of the box, and I'm going to replace the letter k with the number 5. And I'm going to write 1, negative 6, 5, and 12. And I'm going to bring down the number 1. 4 times 1 is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. 5 minus 8 is negative 3. 4 times negative 3 is negative 12. 12 minus 12 is 0. I ended up with a remainder of 0. I have verified that x minus 4 is a factor, and that will take place if k is equal to 5. So therefore, my answer is going to be x cubed minus 6x squared plus 5x plus 12. All right, I would like you guys to please go ahead and try that next problem on your own, making sure that you can do a problem just like this. So please pause the video, try this problem, then restart the video, and we will see how well you do. Okay, So hopefully you recognize that we are going to be working with x equals -2, and we have every single degree represented, 3, 2, 1, 0. So hopefully you put -2 inside of the box, and you wrote down 5, -1, k, and 8. So hopefully you brought down the number 5. -2 times 5 is -10. This will produce a -11. -2 times -11 is +22. This is going to be k plus 22. -2 times this whole quantity is going to be -2k minus 44 if I'm distributing that -2 to every single term. So 8 minus 44, that's going to produce a 36. This is -2k minus 36. Now, this space should equal 0 in order for us to have a factor. So therefore, you should have set 2k minus 36 equal to 0 and solve for k by adding 36 to both sides. We have -2k is equal to 36. Dividing both sides by -2, k is equal to -18. And now verify your answer. So verifying our answer, we should have -2 and 5, -1, -18, and 8. I'm going to bring down the number 5. We have -10. This will still produce a -11. -2 times -11 is +22. -18 plus 22 is 4. -2 times 4 is -8. And voila, there is our remainder of 0. So therefore, our cubic function should be 5x cubed minus x squared minus 18x plus 8. That is the end of today's lesson. If you found that you have any questions on this lesson or you need clarification, please feel free to email me. Otherwise, I hope you have a wonderful day.